Have you ever wondered how a tiny website, maybe a side project, grows to handle millions of users all over the world? What's the secret sauce that keeps it from crashing and burning under all that pressure? Well, today, we're going on that exact journey. We're going to break down step by step how a system scales from literally zero to millions. Let's get into it.
So here's our roadmap. We'll start at the very beginning with the humble story of a single server. Then we'll hit those first growing pains when the traffic just explodes. After that, we'll get into the game of speed and availability, expand our data kingdom, and finally take our system truly global before we zoom out to see the whole shebang. It's a complete build-out from a simple idea to a massive, rock-solid system.
All right, let's kick things off with Section 1, the story of one server. This is pretty much ground zero for every great application out there. Every huge tech company you can think of started right here, a single user connecting to a single server. And on this one machine, we have everything: our web application, all the business logic, and yep, even our database. It's simple, it's clean, and honestly, for a little while, it works perfectly. This diagram really shows you just how straightforward it is at the start. So, a user types your website into their browser. A service called DNS, which is kind of like the internet's phone book, finds the IP address for our server. The user's browser then sends a request straight to our server, which does all the heavy lifting. It processes the request, pulls data from its own database, and sends a response right back. One machine doing absolutely everything. And that brings us to Section 2, when the traffic grew. This is where the real fun and the real challenges begin. Our website is a hit. People are loving it. But our one heroic server is starting to feel the heat. It's getting slow, and we're hitting our very first major bottleneck. So, what do? How do we handle all this new traffic? Well, we've got two main choices, and this slide lays them out perfectly. On the left, you've got vertical scaling. Think of this like one person just getting stronger. You beef up your server with a faster CPU, more RAM, more storage. But on the right, we have horizontal scaling, which is more like building a team. Instead of one superhero server, you just add more regular servers to share the work. And let me tell you, horizontal scaling is how you build truly massive applications. But here's the big, scary question, especially if we stick with that one super strong server. What happens if it crashes, even for a second? The answer is your entire website goes offline. Everything. That's what we call a single point of failure, and it is a massive, massive risk. And this is our solution. Our first major upgrade, the load balancer. Think of it like a really smart traffic cop. It sits right in front of our web servers, and notice I said servers, plural now, and it intelligently spreads out all the incoming requests across them. If one server gets too busy, or heaven forbid it goes down, the load balancer just sends traffic to the other healthy servers. And just like that, poof, we've gotten rid of our single point of failure. Our website is now highly available. Okay, on to our next big challenge in Section 3, the game of speed and availability. Our site is stable now, that's great, but it's also popular all over the world. A user in Tokyo is getting a much slower experience than a user in New York. So how do we make it fast for everyone, everywhere? Before we do anything else, we have to adopt a crucial design principle, the stateless web tier. See, in our old setup, a user's session data, like what's in their shopping cart, might live on the specific web server they're talking to. That's a huge problem. If that server goes down, their cart is just gone. By making our web tier stateless, we move that session info to a shared database. Now, any web server can handle any user's request. This makes our whole horizontal scaling setup way, way more effective. And now for our secret weapon for global speed, the Content Delivery Network, or CDN. The easiest way to think about it is this. A CDN puts copies of your site's static stuff, like images and videos, in data centers all over the world. So when a user in London requests an image for the very first time, the CDN grabs it from our main server. But then, and here's the magic, it saves a copy in London. So the next time someone from that area wants that same image, bam, it's served instantly from the local cache. This is a huge part of how big streaming sites feel so fast. Of course, a CDN isn't a magic bullet without some things to think about. You've got cost, you pay for the data you transfer, you have to set your cache expiry time, or TTL, really carefully so you're not showing people old news. And you gotta have a plan for what happens if the CDN itself goes down. It's these details that really make a system professional. Okay, section 4, scaling the data kingdom. So we've scaled our web servers, we've made things fast globally, but now we've just pushed the bottleneck further down the line. All of our web servers are now hammering our one poor database, and it is struggling to keep up. I mean, think about it. For every one person who's writing new data to your site, like posting a photo, there are probably hundreds, maybe thousands, of people who are just reading data, scrolling through their feed. So with all those users reading at once, how do we stop the database from just grinding to a halt? The answer is database replication. And this diagram shows the classic master-slave model. It's a brilliant idea. All the write operations, like a new post or a profile update, go to one single database, the master. The master then automatically copies that new data over to one or more slave databases. Then all the read requests from our users get sent to those slave databases. See how we just split the workload? It's a game changer for handling read traffic.
And the benefits here are just huge. First, we get way better performance because we can handle tons more read queries at the same time. We get reliability because if one database server dies, our data is still safe and sound on the others. And that leads to high availability. Our site stays online even if a database has a problem. We're building a seriously resilient system now.
Our system is getting pretty robust, but it's time for the next giant leap in Section 5, going truly global. This isn't just about serving users around the world anymore. This is about making our system physically exist around the world. It's all about disaster recovery and the ultimate level of performance. This is so cool. Check this out. On the left, you can see our system running in two completely separate data centers, one on the US East Coast, one on the West. A smart DNS service routes users to whichever data center is closer to them. But now, look at the right. The entire West Coast data center goes offline. Maybe a natural disaster. Who knows? Our system automatically detects this and in an instant redirects 100% of the traffic to the healthy East Coast data center. Our users experience zero downtime. This is high availability on a global scale. It's amazing. Now, I gotta say, this is not easy to pull off. It introduces some really tough new challenges. You need that smart traffic redirection. You have to solve the incredibly complex problem of keeping your data perfectly in sync between the data centers. And you absolutely need automated testing and deployment to make sure both locations are always running the exact same code. And that brings us to our final section, the full picture. We've bolted on a lot of new pieces since we started with that one lonely server. So let's take a step back and look at the complete, massively scalable system that we've built together. And there it is. Just look at how far we've come. You can trace the path of a request all the way from the user through the CDN to the load balancer. You can see our stateless web tier talking to our distributed cache and our replicated databases. We've even added things like a message queue, which helps different parts of our app talk to each other to handle background jobs like sending emails. This right here, this is the kind of architecture that powers the biggest sites on the internet. But what really keeps a beast like this running smoothly? It's these unsung heroes. Comprehensive logging lets us hunt down and fix bugs in a flash. Detailed metrics give us a real-time pulse on the health of our system. And automation? Well, automation is absolutely essential to manage all this complexity. These are the tools that make scaling possible. So our little side project is now a global powerhouse. We've successfully scaled from one user to millions. But the journey in system design, it never really ends. Systems are always evolving. So I'll leave you with this question. What challenges do you think come next? What happens when we need to scale to billions?